Write down. Okay. Okay, fine. See, note down topic. Let's do massive object, very massive object, and very light object, very light object. Yes, yes. Very massive object and very light object collision. Okay. And what type of collision? Elastic collision. Perfectly elastic. Perfectly elastic collision. Perfectly elastic collision of very massive object and very light object. Okay. Like for example, one object has mass 100 kg, other object has mass zero point 0.1 kg, okay, 0.1 kg or 1 kg. So when heavy object collide with light object means mass is less. Light object means mass is less. Massive object means more mass, more mass. Like planet, Jupiter. Planet Jupiter is very massive. But if you see some comet, so mass of comet is very less. Mass of Jupiter is very high. Okay, Earth, Earth is also like that. Earth mass is very large, but some comet is mass is very less as compared to Earth. Correct. So comet is hitting Earth. Okay, fine. So massive object and light object. So let's do one derivation. And what type of collision we are doing? Perfectly elastic. So draw one diagram. Suppose this is the object has mass small m, and this is the object has mass capital M. Capital M. The small m is moving with velocity u1, and capital M is moving with velocity u2, right side. So their speeds are u1 and u2. It is head-on collision. Okay, it is head-on collision. Oblique collision in NEET it is very less. They ask, okay, oblique, but still we will do later. It is more towards J oblique collision. We are not doing, okay, but later we will try later. Okay, so mostly NEET they ask head-on collision. Okay, fine. So this is light object, mass is very less. This is heavy object, mass is very large. So this is before. Now which is greater, u1 or u2? u1. u1 is greater, then only they will collide. Otherwise no collision. u1 is greater than u2. And after collision, their velocities v1 and v2. Okay. Now you do momentum conservation. First you do momentum conservation. mu1 plus capital M u2 is equal to mv1 plus capital M v2. Now E formula. What is E formula? v2 minus v1 by u1 minus u2. Okay. And perfectly elastic collision is 1. So v2 minus v1 is equal to u1 minus u2. Now you have two equations. Now you have two equations, this equation and this equation. This is from momentum conservation. Momentum conservation, and this is E formula, coefficient of restitution. Okay, fine. Now we have to find V1 and V2. So what is the condition here? Capital M is very large. Capital M is very, very greater than small m. So let's find V2. Let's find V2. Let's find V2. How to find V2? What I have to do? Tell me. How to find V2? Now one equation is this, another equation is this. So I am writing both. You do one thing, you divide by small m. You divide by small m. This divide by small m. So what you get? U1. Actually, we can divide by capital M also. V2 we have to find. Okay, let's divide by capital M. Wait. Let's divide by capital M. Divide by capital M. Divide by capital M. What do you get? M by capital M U1 plus U2 is equal to M by capital M V1 plus V2. Now find V1 from here and put it here. V2 is there. Okay, you subtract this. Better you subtract, no problem. Subtract it. This is first equation, this is second equation. 2 minus 1. Oh, I should write like this. I should write, wait, I should write like this. Interchange. M by capital M V1 plus V2 is equal to M by capital M U1 plus U2. Now you add these two. First equation, second equation, add. No, sorry, sir, not add. Subtract. Subtract 2 minus 1. Subtract 2 minus 1. So this minus this. So M by M V1 plus V2 minus this. Is equal to this minus this. Minus this. Sorry. Yeah, V2 minus V1 cancel. V2 minus V2 cancel. Sorry, V2 minus V2 cancel. Okay, clear. Then you have M by capital M V1 plus V1 is equal to M by capital M minus 1 U1 plus 2 U2 plus 2 U2. Okay, clear. Now you see M, capital M is very, very greater than small m. So M is very, very less than capital M. So M by capital M can be taken as 0, nearly. Small m by capital M is nearly 0. Like for example, M is 0.1 kg and capital M is 100 kg. So what is a small m by capital M? 0.1 by 100. What is 0.1 by 100? 0.001. So it is nearly 0. Okay, nearly 0. So put here 0. 0. 0 V1 plus V1 is equal to, this is also 0. 0 minus 1 U1 plus 2 U2. So what is the value of V1? 2 U2 minus U1. So V1 is equal to 2 U2 minus U1. Note down. V1 is 2 U2 minus U1. And what is V2? How much is V2? Now for V2, you can use this. V2 minus V1 is U1 minus U2. V2 minus V1 is U1 minus U2. Now V1 is this. So V2 is equal to V1 plus U1 minus U2. Now V1 is this. So 2 U2 minus U1, this is V1 plus U1 minus U2. So what is the answer? 2 U2 minus U2. 2 U2 minus U2. U2. So V2 is equal to U2. V2 is equal to U2. Note down. V1 is equal to 2 U2 minus U1 and V2 is equal to U2. Note down. It means the massive object velocity not change. Velocity of massive object not change. Velocity of massive object does not change. Velocity of massive object does not change. V2 and U2 are equal. So massive object, what is the velocity before? Massive object, what is the velocity before? U2. Now also U2. So massive object velocity not change, but light object velocity changes. How much? 2U, 2U2 minus U1. Correct, good. 2U2 minus U1. Memorize this. 2U2 minus U1. So very light and very massive. U1, U2. So this is 2U2 minus U1 and this is U2. 2U2 minus U1. Okay, note down. So V1 is equal to 2U2 minus U1 and V2 is equal to U2. Okay, memorize it. You can memorize like this. First object small m, second object capital M, very large. This is very massive, like truck, cycle, truck, or you can say ant, elephant, ant and elephant. Okay. So velocity of light object U1, velocity of massive object U2. Now this is before and after light object is 2 U2 minus U1 and very massive U2. Note down. Memorize this diagram. This is perfectly elastic. Okay, perfectly elastic collision. Perfectly elastic collision. Okay, clear? Now solve this question. Suppose this is 1 kg, 1 kg is going with 1 meter per second and this is 100 kg. 100 is 100 kg is going right side with 0.5 meter per second. Tell me, what are their velocities? What is the velocity of 1 kg? What is the velocity of 100 kg? Use the direct formula. Direct formula. What is the direct formula? 2U2 minus U1. This is V1. and this is V2. V2, U2, same. What is V2? So what is V2? 0.5, 0.5. Good. So massive object velocity not change. Velocity of massive object does not change. Now calculate this V1, 2U2 minus U1. So what is the answer? 0. So it will come to rest. This will come to rest. Okay, clear? One more example. Suppose this is 1 kg, it is going with 2 meter per second, and this massive object is going left side with 1 meter per second. So tell me, what is the velocity of massive object? So this is small object is going right side with 2, massive object is going left side with 1. So what is the final velocity of massive object? Minus 1. It will be left only. No change. Massive object, no change. Same. Okay, now calculate value. Now sign convention. Plus means right side, minus means left side. Remember, okay, right side means plus, left side means minus. What is U1? U1, 2, U2 minus. Very good, minus 2. So calculate. No doubt. U1 is plus 2. U2 is minus 1. U1 is plus 2, U2 is minus 1. Okay, substitute 2U, what is the formula? 2U2 minus U1. So 2 into minus 1 minus U1. So minus 2 minus 2, okay, minus 4. Minus 4 means left side. So that means the light 1 kg object will go left side with 4 meter per second. Okay, clear? Note down. Let's take one more example. Suppose massive object is going right side with 2 meter per second, and light object is going left side with 3 meter per second. Now this is U1, this is U2. Massive means 2, light object means 1. Okay, think like this: 1, 2. So question is like this: a very massive object is going right side, very light object is going left side. Massive object right side, left side. Okay, understood? They are coming like this. So this is 1, this is 2. So what is U1? Tell me, what is U1? Minus 3. U2 plus 2. Now calculate V2 and V1. Calculate V2 and V1. Massive object means 2. Light object means 1. So what is V2 and V1? Calculate. What is V2? V2, 2. 2 meter per second. No change. Massive object, no change. Massive object, no change. And what is the formula for V1? You apply 2U2 minus U1. Good. 2U2 minus U1. So now substitute. U2 is 2. U1 is minus 3. So 2 into 2 minus 3. So 4 plus 3 7. 4 plus 3, 7. Okay, clear? Understood? Done. Okay, finish. This topic finish. Means massive and light object, finish. Okay. Now next. Like this we will do 4 to 5 topics we will do. Up to 10:30 we will continue. Okay. So very massive object collide with light object. So massive object velocity no change and light object velocity change. The formula is 2u2 minus u1. Okay, next we will do bullet and plank. Note down. Bullet and plank. Suppose this is the wooden plank. It is fixed wooden plank, fixed. Now one bullet is coming with velocity u and the length of this wooden plank is d. It is d. So the bullet will hit the plank, it will penetrate, bullet will penetrate plank, bullet will hit. You see some bullet is coming, it will make hole, correct? Embedded, that is known as embedded. Embedded. Okay. So when it is embedded, what is the final velocity? 0. Sometimes final velocity is not 0, it will come out. It may come out. It may come out with less speed. It may come out with less speed. Suppose it is going with what speed u, it may come out with u by 3 or u by 2 or u by 4, correct? So how many planks are needed to completely stop it? That is the question. So you write down, here you write down u by n, u by eta you can assume or n you can assume, okay, n. So what is the velocity before collision with the plank? U. After collision, u by n. So how many planks are required to completely stop? To completely stop it. Okay, so this is kinematics question also, but this is given in collision also. So in collision also it is given. So how to solve? So you can solve like this: loss in kinetic energy in one plank. In one plank, how much is loss in kinetic energy in one plank? Half m u square minus half m u by n whole square. This is the loss. So how much? Mu square by 2 common, 1 minus 1 minus 1 by n square. Okay, this is the loss in one plank, loss in kinetic energy when one plank is there. Okay, So that is equal to work done by a force. So suppose retarding force is F, retarding force is F. So FD, this is equal to FD, okay, FD. Now loss in kinetic energy for n planks, n planks. So what is the loss in kinetic energy when n planks are there? Half initial kinetic energy half mu square, final kinetic energy 0. It will come to rest. It will come to rest. It will come to rest. So final kinetic energy 0, initial half mu square. So this will be equal to F into ND. What is the length of one plank? D. So what is the length of n planks? ND. 1, 2, 3 and so on. Okay. So bullet is going with the speed u, and finally its velocity will be 0. Final velocity 0. So this is equal to F into ND. Now divide these two, this by this. Let's finish this topic fast. 1 by 2 mu square 1 minus 1 by n square divided by 1 by 2 mu square is equal to Ft by NFD. FD cancel, half mu square cancel. So what is the answer? 1 minus 1 by n square is equal to 1 by capital N. So what is capital N? Or you can solve like this: n square minus 1 by n square is equal to 1 by n. So what is capital N? N is small n square by small n square minus 1. Okay, note down. Capital N is equal to small n square by small n square minus 1. So let's solve one question. Bullet hits a plank. Bullet hits a plank with speed u. With speed u. It is a fixed plank. Okay, it is a fixed plank, like wall, like fixed ball. So it comes out with speed. With what speed it comes out? Suppose u by 3. Let's take u by 3. Bullet hits a plank with speed u. It comes out with speed u by 3. How many extra means more? How many more planks are needed to completely stop it? How many more planks are needed to completely stop it? To completely stop it. How many more planks are needed to completely stop it? So what is the value of n? You tell me, what is the value of n? 3. So what is capital N? 3 square by 3 square minus 1. So how much? 9 by 8. 9 by 8 means 1.11, right? No. 1.125. 1.125. So complete number of planks will be 2. So extra how much needed? 1. Complete number. Total how many planks needed? Total how many planks needed? See, if n is 1.5, so take n is 2. Okay. If n is 0.8, then you take n is 1. If n is 2.3, so take n is 3, complete number. If n is 4.6, so take n is 5. Okay, complete number you have to take. So what n value you are getting? 1.125. So complete number 2. But question is asking what? Extra. So how much extra? 1. 1 already there. This is the 1 plank. So extra plank needed is 1. Extra plank needed is 1. Okay, solve this question. While passing through plank, 50% kinetic energy is lost. 50% kinetic energy is lost. How many extra planks or more? How many extra or more planks needed to completely stop? To completely stop it. To completely stop it. Okay, note down. So, while passing through plank, how much energy is lost? 50%. Good. Suppose 100 joule is there. So after passing through plank, what is the energy? 50 joule. Okay. But formula is in terms of U. Correct. So U by N. Okay. Formula is in terms of U by N. So can you find out N here? Can you find out N in this question? N, small n. Okay, find small n. How to find small n? Once you find small n, then use this formula. What is capital N? N square minus 1. Okay, how to find small n? Okay, tell me. Suppose initial kinetic energy is K. What is the kinetic energy after one plank? 50% lost. How much? K by 2. Good. Now this is half m U square and this is half m V square. Now half m V square is 1 by 2 times of half m U square. So what is V square? What is V square? U square by 2. So what is V? U by root 2. So what is n value? N, small n. Root 2. Small n is root 2. Are you getting? Suppose the bullet is coming with velocity u. So after one plank, what is the velocity? U by root 2. Clear? 50% lost. While passing through plank, 50% kinetic energy lost. So how much is lost? Half. Half kinetic energy lost. So what is the kinetic energy before? K. Now how much? K by 2. So now velocity you can take u. Velocity u. After what is the velocity? V. So half mv square is equal to K by 2. Are you getting or not? So half mv square is half 1 by 2 mv u square. Okay, half of cancel. So v square is u square by 2. So v is u by root 2. So what is n? Root 2. So what is capital N? Solve this. Capital N. N square n square by n square minus 1. So 2 by 2 minus 1. So 2. So total planks needed is total 2. So extra Planck needed 1. Extra Planck needed 1. Okay. Now you can solve 25%. If 25% kinetic energy lost, try this question. If 25% kinetic energy is lost, so suppose initial kinetic energy K, what is the final kinetic energy? K by 4 or 3K by 4? Lost is 25%. 25% is lost. What is 25% of K? 25% of K means how much? 0.25K. 0.25K how much? K by 4, correct? Are you getting or not? K by 4. So how much is left? 3K by 4. Okay. So lost is 25%. So left is means retained. That is known as retained. Kinetic energy retained. Kinetic energy retained means remaining. Retained means remaining. Like suppose 100 joule. Suppose 100 joule. So how much is lost? 25 joule lost. So how much is retained? 75. That is remaining. Now calculate this. So half mv square is equal to 3 by 4 into half m u square. So half of cancel, cancel. So what is v square? Correct. 3 by 4 into u square. So what is v? Root 3 by 4 into u means v is equal to root 3 by 2 into u. So v can be written as u divided by 2 by root 3, correct? Are you getting or not? V is equal to root 3 by 2 u. So v is equal to u by 2 root 3. This is clear? So this is the value of n. So n is equal to 2 by root 3. So what is capital N? N square by n square minus 1. Now do the squaring. N square. So what is n square? 2 square by 3. 2 square by 3. Tell me. 4 by 3 divided by 4 by 3 minus 1. So how much? 4 by 3 divided by 4 by 3 minus 1 means 1 by 3. Good. So what is the answer? 4. Total Plancks needed 4, but 1 already there. So how many extra? 3. So extra required 3. Extra 3 are needed. Extra 3 are needed. Okay. Okay, fine. So this is over. Okay, Planck is over. Note down. Okay, this is wood and Planck. Okay, so you revise it again and again. You revise. I will give you page number. Give me book. You give a book. So Planck and wood, Planck and bullet, bullet and Planck. It may be in collision. I will check if any question is there. Center of mass and collision. Or it may be there in kinematics. I think it is there in kinematics. But this is also collision. I will just give you page number and question number, then you can do in homework. Okay, I am not finding any question like this. Okay, later we'll search. Okay, fine. Next you write down hanging block and bullet. Hanging block and bullet. Suppose this is the hanging block, this is the ceiling, this is the ceiling, and here one block is there. Now we have a bullet. Bullet is coming with velocity u. Bullet is coming with velocity u horizontally, and this is the hanging block. What is the initial velocity of block? 0. And what is the u1? U. m1 m, m2 capital M. Okay. So this is before collision. Note down, this is before collision. This is before collision. Now this is the string, this is the block. The bullet is coming with speed u. It will hit the block like this. It will hit the block. So block will go along circle because string is connected. Now two cases possible. Note down, 2 cases possible. First case, bullet gets embedded. Bullet gets embedded. What do you mean by embedded? Absorbed. Embedded means absorbed. So it will be like this. If bullet is absorbed, like this, then block and bullet will go together, correct? It will go together. So note down, bullet gets embedded means block and bullet go together. Block and bullet go together. Suppose this is the block, this is the bullet. Okay, bullet will hit it and they will go together like this along the circle. They will go along circle. Now the bullet is inside. This is the bullet. Bullet and block going together. What is the final velocity? Suppose v. So V1 and V2 both are equal to V. So what type of collision is this? Perfectly elastic or inelastic? Inelastic. Perfectly inelastic. This is perfectly inelastic. Length is L. So they will go along a straight line, or they will go parabola or circle. Circle. So they will go circle. So suppose they will come up to here. So what is the total mass? M plus M. How much angle it is making? Maximum angle making theta. So V2 is 0, or you can say V dash. Let's take V dash. This is V dash. Okay. So what is velocity after collision? Calculate momentum conservation. You do momentum conservation. First you calculate V. Calculate V. So solve. Calculate V. Momentum conservation. How to do momentum conservation? What is initial momentum of bullet? Mu. Initial momentum of a block? 0. M into 0. And final momentum system? M plus M into V. Very good. So M into U is equal to M plus small m into V. So calculate V, mu by M plus M. Note down. So this is the velocity of block and bullet together. Okay, they go together. They go together, or you can say common velocity. They have common velocity means same velocity. Same velocity. So what is the same velocity? Mu by M plus M. Mu by M plus M. So now you got V. You got V as mu by M plus M. Now do energy conservation. Mechanical energy conservation. So how much height it is going? H. So what is the kinetic energy here? K1. Potential energy here? U1. So tell me, what is kinetic energy here? System kinetic energy. Half system. Half M plus M V square. Very good. U1 0. This is 0 level. Okay. You can take this as 0 level. This is 0 level. The direction of bullet is going in which direction? 0 level. Okay, understood. So what is U1? 0. What is U2 here? MGH. So M plus M GH. So U2 is M plus M into GH. What is K2? K2. 0. It will go like this. Now use K1 plus U1 is equal to K2 plus U2. Okay, solve. So this is kinetic energy plus potential energy conserved. What do you call this? Conservation of mechanical energy. What is mechanical energy? Mechanical energy, sum of kinetic and potential energy. Sum of kinetic and potential is known as mechanical energy. Okay, now equate. So you will get 2gh actually, square root of 2gh. Okay, so half m plus m v square is equal to m plus m gh. Okay, So V square will be 2GH. So you have H is equal to V square by 2G. H is equal to V square by 2G. And what is V square? M square U square by M plus M whole square. M square U square by M plus M whole square into 2G into 2G. So this is the H. Okay. So understand this. So first, what is going on? The bullet is coming with speed u. Block is there, rest. Block is rest, hanging. Bullet gets embedded. Embedded means absorbed. So they go together. Same velocity, common velocity, v. Momentum conservation, mu plus 0 is equal to m plus m into v. Okay, so v you are getting mu by m plus m. Now next, the block and bullet will go together. Block and bullet will go together. Final velocity 0. Then again it will come back. They will oscillate. They will oscillate. Okay. So maximum height it is going how much? H. So that formula is this. Okay, clear? Mechanical energy conservation. Then angle, how will you find angle? Length of the string is L. Length of the string is L. So what is this? This is L cos theta. So how much is this total? This is also L. So how much is this? Tell me. L minus L cos theta. Remember this. L into 1 minus cos theta. Okay, fine. Now what is the second case? First case is embedded. First case is embedded. Second case. So what is the second case? Bullet hits block, bullet hits block, but not embedded, it comes out and comes out. Bullet hits block and comes out, pierce, it will pierce, penetrate, it will come out like this. You have seen in some movies, they show this type of scene, one bullet is coming, actor, hero is firing bullet, now two villains are there. Some movies I have seen this type of, it will penetrate the head of first person and the same bullet is hitting the second person also. Have you seen? Yes. Okay. So like this, one block is there, another block is there. Suppose bullet is coming, it will penetrate the first block, but it is not embedded. It will come out with same speed or less speed. Less speed, then it will hit the second block. Okay, like this. Okay, so let's do that thing. Note down. Second case, bullet hits block and comes out. Bullet hits block and comes out. So let's draw diagram, that is better. So you draw diagram like this. Suppose this is the block, this is the bullet. Mass of bullet m, mass of block capital M, velocity of bullet u, block is at rest. So this is before collision. Note down, this is before collision. Now after collision, The velocity of bullet is v1 and velocity of block is v2. And block will go to this height. So this height is h. What height block will go? Tell me. What is the velocity of block after collision? v2. So how much height it will go? So we can use the formula. The kinetic energy gets converted into potential energy. Small m or capital M? Capital M here. Kinetic energy of block gets converted into potential energy. What is the final velocity here? 0. Correct or not? So what is v2? Root 2gh. So velocity of block is root 2gh and velocity of bullet is v1. Then conserve the momentum. Mu plus m into 0, correct, is equal to mv2 plus small m v1. So mu is equal to mv2 plus mv1. Okay, note down. So same thing only, just not embedded. It is coming out, emerging. This is known as emerging. Bullet emerges. Emerges after hitting block. After hitting block. So bullet is coming with what speed? U. Block, what is the speed? 0. Now bullet is hitting the block. Not embedded. Bullet comes out from other side. With what speed bullet comes out from other side? v1. But block also go right side with v2. But block is connected with string. So it will not go horizontal, it will go circle. It will go along circle. Circle means after some time come to rest. So how much height it is gaining? Root 2gh. So v2 is equal to root 2gh. Okay. So h is equal to v2 square by 2g. H is v2 square by 2g. Then you can conserve the momentum. Okay, momentum of bullet plus block before is equal to momentum of bullet plus block after. So this is after collision. This is after collision. Then this v2, so mu plus m into 0 is equal to mv2 plus mv1. So v2 value you can put from here. So mu is equal to capital M root 2gh plus small m v1. Then you can calculate v1. So mu minus capital M root 2gh is equal to mv1. So v1 is equal to, now divide by small m, mass of bullet. So mu by m minus capital M by small m root 2gh. So this will be u minus m by m root 2gh is equal to v1. Okay. So with what velocity bullet comes out? If block is going up to height h, so with what velocity bullet comes out? U minus m by m into root 2. Okay, clear? So you derive it, okay? See, derivation is also important. Only formula is all you remember not good. You learn the derivation also. Learn the derivation, and for exam you memorize this direct formula. So there is a PYQ also. We'll do one PYQ. So note down. Then we'll continue later. Now this is there in collision, I think. Eleventh question, page 399. This is AIPMT 2016. Okay, PYQ it is. Solve this question. So what is the question? Bullet of mass 10 gram moving horizontally. Bullet of mass 10 gram moving horizontally with what speed? With what speed bullet is moving? 400 meter per second. Strikes a wooden block. Strikes a wooden block. You have this book, everyone. Strikes wooden block with what speed? 400. What is the mass of wooden block? Mass of wooden block 2 kg, suspended by light inextensible string of length 5 meter. Suspended by light inextensible string of length. So you pick up the values. What is the U given? 400. And what is the L given? 5 meter. What is the mass of block? 2 kg. Mass of bullet, small m, 10 gram. As a result, center of gravity of block is found to rise vertical distance 10 centimeter. So basically block is rising by what height? Block rises 10 centimeter. So what is given? H. H is given. The speed of bullet after it emerges out horizontally. The speed of bullet after it emerges out horizontally from the block. So what they're asking? What they're asking? V1. Speed of bullet after it emerges out from block. After it emerges out from block. Okay, clear? So this is the question. So basically this is the formula. That formula you can apply. U is given, small m is given, capital M is given, H is given. H. Length not needed. Length of a string not needed. If angle theta asked, then it is needed. What is the formula for H in terms of L? L minus L cos theta. If theta they are asking, then you can use L. So H directly given, H given directly, H. Okay, solve. Tell me, solve. You can use that formula. Calculate. Use a direct formula. Put the value Once again, little bit I am revising. Bullet is coming with U, block at rest. Bullet hits block. Bullet comes out, pierces, emerges. Bullet comes out with V1, block, V2, block will go to height H. That height is V2 square by 2G. Momentum conservation. This is the formula. Tell me which is correct answer. Calculate. Which one? Tell me, tell me. 120. Okay. So, okay, revise it. If not understand, I will teach again, no problem. Okay, revise it. So just substitute the value and tell me what is the answer. Okay. Okay, fine. Then we'll continue.